Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 5 Additional Mathematics Chapter 1 Circular Measure Long Question Example 5. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. The diagram shows two circles with centers A and B respectively. The circle with center A has a radius of 8 cm, which is over here, while the circle with center B has a radius of 6 cm, which is over this one. The two circles meet at point X. A and B is a straight line. DC is parallel to AB. Okay, both DN and CM are perpendicular to AB. Continue to read the question. Given that angle DAN is equals to 30 degree, calculate the length of DN, angle CBM in radians, the length of DC, and the area of the shaded region. So this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries, I'm going to show you the step-by-step working and the solutions. So without further delay, let us start to solve the question. Okay, let us find the length of DN now. Okay, to find the length of DN, we can use the trigonometry concept, guys. As you can see over here, length of AD is given, which is 8 cm. Okay, and they already give the angle which is in the degree form, which is 30 degree. The only thing we don't know is the length of DN. It is possible for us to find the length of DN using the trigonometry rule. Okay, so to find the length of DN, we're going to use the sine rule. So from here, sine 30 degree will be equals to, okay, just a quick recall, guys. Okay, sine theta will be equals to opposite over adjacent. So in this case, our opposite is DN, which is the one we are going to find out. Okay, and then you divide with hypotenuse. In this case, hypotenuse is length of AD, which is 8 cm. Okay, so to find the length of DN, what you do, 8 you times with sine 30 degree. Okay, since in question part A they ask us to find the length of DN, okay, you no need to convert this degree angle into the radian. Okay, there's no necessary for it. So you calculate this, you should get your length of DN is equals to 4 cm, 4 cm. Okay, let me underline the solution for the question part A. Okay guys, it's pretty short question for the part A. So let us proceed to the question part B, where they require us to find the angle of CBM in radians. Okay, so since the length of DN is equals to length of CN, so it is possible for us to calculate the angle of CBM over here. Okay, also using the trigonometry concept. Okay, so let me write here the 4 and 4. At least it will be easier for you guys to see the explanation. Okay, in this case, we are also use the sine formula, trigonometric function. So from here, sine CBM, sine angle CBM, okay, is equals to opposite. Okay, your opposite is 4 cm. Okay, and then you divide with the hypotenuse 6 cm. Okay, so from here, but then be careful, guys, they ask you to calculate in radians. Okay, you can show in your working in degree and then you convert to radian, or you can straight away press the calculator and you can get your answer in radians form. It is up to you. Okay, but then since it is a 2-mark question, I think it is better for us to show in degree form and then later on we convert into radian form. Okay, so from here you should get your angle CBM is equals to, okay, let me calculate this. Okay, sine inverse 4 over 6, you should get 41.81 degree. Okay, but this is not the final answer. We still need to convert into the radian form. So what you do, you times with pi over 180 degree. Okay, close bracket. So now you calculate this. So from here you should get your angle of CBM in the radian form. Okay. So from here you should get your answer is 0.7297 radian. 0.7297 radian. Okay, this is the answer for the question part B. Okay, so let me underline the solution for the question part B. Okay, so from here let us proceed to the question part C now. Okay, in the diagram, as you can see here, to find the length of DC, it is actually equal to the length of the NM, if you notice carefully over here. Okay, so from here what we can do is, the first step is we can find the length of NM and then we can equate it to the length of DC. Okay, so in order to find the length of NM, what you need to do, you need to find the total length, guys, over here, which is the length of AB, and then you need to minus the length of AN, and then you need to minus the length of NB. So from there you should get your length of NM, and then you equate to the length of DC. So I hope you understand the concept behind this. Okay, so let me write down in the working over here. So from the diagram, okay, like I said, we know that the length of DC is equals to the length of NM. So from here the first step is we need to calculate the length of AN. So from here, step 1, find length of AN. So how to find the length of AN? We can use the Pythagoras theorem rule, guys. Okay, we know the hypotenuse, we know the opposite length. So the only length we need to know is the adjacent length. So it is possible for us to calculate using the Pythagoras theorem. So from here, so to calculate the length of AN, so will be equals to 8 square minus with 4 square, and then you square root it. Okay. Okay, guys, you calculate the length of AN. Okay, let me press my calculator. So 8 square minus 4 square, square root, you should get 6.928 centimeter. Okay, this is for your step 1. You find the length of AN. Okay, I hope my explanation clears you till now. Once we're done with the length of AN, so the next step what we're going to do is we're going to find the length of MB. Okay, so let me write down in the working here. So the step 2, find the length of MB. Okay, so let me underline this. So similar as the first step, so the second step also you can find using the Pythagoras theorem. Okay, in this case, to find the length of MB, so 6 square you minus with 4 square, and that answer you square root it. Okay, so MB will be equals to 6 square minus with 4 square, and then you square root it. Okay, so from here you should get your length of MB is equals to, okay, let me press my calculator. So 6 square minus 4 square, okay, square root, you should get 4.472 centimeter. So this is your second step. Okay, so once you're done with the second step, so now you can able to find the length of DC. Okay, since I mentioned that the length of NM is also equals to the length of DC, so to find the length of DC, what you do, okay, AN you minus with, AB you minus with AN minus with MB. Okay, so from here, step 3, find length of DC. Okay, let me underline this. So from here, DC is equals to, okay, let me scroll it up. So AB minus with AB minus with AN minus with MB. Okay, AN minus with MB. Okay, so from here your DC will be equals to, so AB, how to find? Okay, very easy guys. So AX is actually 8 and then XB is actually 6. So the total length AB will be 8 plus 6. So from here you should get your length of AB is equals to 14. Okay, so from here your AN will be 6.928, so you minus with 6.928. Okay, and then you minus with MB, which is 4.472. Okay, so you calculate them all. So from here you should get your length of DC. Okay, let me calculate this. Okay, from here you should get your length of DC is equals to 2.6 centimeter. Okay, so let me underline the solution for the question part C. Okay, so that is all for the step-by-step working and solution for the question part C. Okay, from here let us proceed to the question part D. Okay, for the question part D, I think it's better for me to screenshot the image, okay, rather than scrolling up and down. Okay, that's why I did in this way, and of course it will be easier for me to explain to you. Okay, so from here, to find the area of the shaded region, so what you're going to do is, the first step is we're going to find the area of trapezium. So can you notice the trapezium over here? So the first step what you're going to do is we're going to find the area of the trapezium, which is the overall area over here, bounded over here. Okay, and then what we're going to do is we're going to minus off with the 2 area of the sector. Okay, can you see the 2 area of sector consists of DAX. Okay, this is the first sector, and then CXB. So this is the second sector. So you minus them out, you should get the area of shaded region, which is DCX. Okay, so this is the overall idea on how we're going to solve this question. Okay, so I hope you guys are clear in order to solve this question. So to get the area of shaded region, okay, let me write this area of shaded region, okay, will be equals to area of trapezium, okay, which is the overall bounded area guys over this region. Okay, and then you minus with the area of sector DAX, okay, sector of the circle DAX, okay, and then you minus the area of the sector CBX. Okay, so this is the overall idea. Okay, let us find them one by one. So from here, area of trapezium, okay, we can use this formula, half, okay, times with the summation of the length, okay, of the parallel side. Okay, so from here the DC we calculate already in the question part C, which is 2.6, okay, and then plus with the length of AB, which is 14, okay, close bracket, and then you times with the height of the trapezium, which in this case is 4 centimeter. Okay, so this is your area of trapezium. Let me square bracket this. Okay, so at least you can differentiate the working. Okay, and then the area of sector DAX. Okay, so from here the formula to find the area of sector of the circle is half r square theta. So from here your radius is 8 centimeter, half, okay, times the radius 8 square. Okay, but then you have a catch here. You have an angle here in degree, but then the formula requires us to find in radian. So what you need to do, you need to convert this 30 degree into the radian. So from here, okay, just I write my working over here. So 30 degree, okay, you convert to pi over 180 degree. Okay, so from here you simplify this, you get 1, you simplify this, you get 6. So from here you should get your angle is pi over 6 radian. Okay, you also can write in this form guys, okay, just for your information. Okay, pi over 6 radian. Okay, let me square bracket this as well. Okay, this is for the second, this is for the first sector of the circle, which is the DAX. Okay, as for the second sector of the circle, CBX, okay, similar formula, half r square theta, okay, half, okay, times with the sector, radius of the sector, 6 centimeter, so 6 square, okay, and then you times with the angle. Okay, the angle we find in the part B, which is 0.7297. okay, wait on guys, so let me shift my working over here. Okay, minus 0.7297. okay, you calculate them all. Okay, let us start to calculate with trapezium. So from here you should get your trapezium. Okay, let me calculate this. 2.6 plus with 14, okay, you should get 16.6. okay, 16.6 you times with 4, you should get 66.4, 66.4, and then you divide with 2. So from here you should get 33.2 centimeters square. Okay, then proceed to find with the area of sector of the circle, DAX. Okay, half times with 8 square times with pi over 6 radian. So from here you get 16.755 centimeter square. 16.755. Okay, and then the second area of sector of the circle, half times with 6 square times with 0.7297. Okay, you calculate this, you should get 13.1346. 13.1346. okay, hang tight guys, we are very close to our final answer. Okay, so from here 33.2 minus 16.755 minus 13.1346, and yes, we get the answer is 3.3104, but we can write here in approximation where your answer will be 3.31 centimeter square. Okay, let me underline the solution for the question part D, guys. Okay, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Thank you everyone for your support, and I'll see you in the next video.